Hey everybody, thank you for coming to DEV372, Infrastructure is Code with the AWS Cloud Development Kit. My name is Jason Fulgham. I'm a dev manager for the AWS CDK project. And we also have Elad Ben Israel here with us today. Elad's our principal engineer for the CDK. So in the next hour, Elad and I are going to take you on a tour of the CDK and show you this new software development framework for defining your cloud infrastructure as code. Our session is going to be split up into 4 parts today. We're going to start by giving a little bit of context and talk about our journey through infrastructure management, talk about some of the challenges that developers face, and some of the best practices that have emerged. Then we're going to quickly give you an overview of some of the main core concepts you need to know to work with the CDK. And we're really going to spend the bulk of our time in this session in demos. So we've got a pretty fun little demo application we're going to build from scratch using the CDK. And we're going to see how the CDK really changes the developer experience around defining your infrastructure. And finally, we'll wrap up with some recommendations on where to go to learn more about the CDK. So I'll turn things over to Elad to talk about infrastructure management.
Thanks. Hey guys, welcome. Thanks for coming. We're pretty excited to be here and talk to you a little bit about this project we've been working on. Before we get into coding, which is basically what this thing is about, let me tell you a little bit about my journey around infrastructure management. So I used to work for Amazon.com before joining AWS, the retail website. And as you know, Amazon is an AWS customer, and we use AWS like anyone else. And my team initially had a pretty simple service. We had a bunch of EC2 instances, consuming messages from an SQS It's a pretty classic architecture for a retail team. It's quite scalable. It can handle a lot. And the way we manage our infrastructure was basically go to the AWS console, log in, and we had a pretty pleasant experience. Click through some buttons and change some knobs and provision our queues in our fleet. And whenever we needed to create another environment, we had a little document, and people followed that little document and created these couple of resources. And that model sustained quite well for quite a long time. But then 2 things happened. Well, gradually 2 things happened. One is we needed to provision more and more environments. I'm sure many of you run into this. You expand to a new region, you need test environments, integration environments, development environments, and so many people needed to create these resources. The other thing that happened is that there were new services coming in, and we wanted to leverage them. DynamoDB came out, Kinesis came out. Our service became more and more complex and relied more and more on those resources. And our little document became a big document. And people started making mistakes, and it took a long time, more than we wanted. And so obviously, as a coder, I was like, let's find a way to codify this problem and automate it. And so I ran over and picked up the Ruby SDK, which is really awesome, and started writing a little Ruby program to provision my resources. And that turned out to be pretty useful. Like, we could literally throw away this document, and now everybody that needed a new environment just ran this program, and voila, you got yourself a stack deployed. So that was a huge improvement, and it worked really well until we actually wanted to change things, right? And so when you want to change things, you can't just create those resources. You actually need to update them. And I find myself dealing more and more with that aspect of how to provision my infrastructure, right? Because some people had environments in different stages. So this code, it needed to take into account the current state and figure out what's the next state, how to update. What happens if it doesn't work? How do you roll back? It's all kind of OK for development and testing, but when it comes to production, it becomes not kind of OK to miss things like that. And so at some point, we realized this model doesn't sustain anymore. And we found out about provisioning engines, which I'm sure most of you are familiar with. Resource provisioning engines are very powerful tools that let you think about your infrastructure a little differently. Instead of thinking about what set of operations I need to issue against the service in order to provision my resource, I can think about what is my desired state. I define my desired state using a configuration file. CloudFormation, which is the provisioning engine for AWS, uses a file called AWS CloudFormation templates. Terraform is a very popular provisioning engine used by AWS customers, and they use HCL as a configuration file format. But essentially, they work the same way. You hand them over this desired state configuration file, and they look at your stack and determine what are the steps that need to be executed in order to reach that desired state, which is exactly the problem that I was trying to solve at that time. And it's pretty magical, right? Like, you really think declaratively about where you want to be, and all the heavy lifting happens in the provisioning engine. Rollbacks, updates, it's pretty cool. However, at some point, I find myself spending full days of copying and pasting YAML files. And that didn't feel right. Like, it didn't feel like what I need to do in order to create like reusable things or create multiple instances of something. And I needed a better solution, and my intuition was that this file is not something that humans need to write. Like, it's basically a big list of resources and properties. It felt like an assembly language more than an actual programming language. And so obviously, I went over to the internet and found these really awesome community-driven projects that allow you to generate CloudFormation templates. It's a pretty natural thing to do, right? Like, when you have a big configuration file. And there are a couple really awesome projects, a few really awesome projects. Troposphere is probably one of the most popular ones. It's in Python. It has this really nice class library that allows you to basically not interact, but like produce the CloudFormation template through code. And so back to code, and that's where I feel comfortable, at least. And I can define my infrastructure logic again. I can create for loops and if statements and basically create a mental model of what I'm trying to do instead of actually copying and pasting JSON files. We're still using the desired state model. We're still defining what we want and not how to get there. But what happened is that instead of copying and pasting JSON and YAML, I found myself copying and pasting Python code. We had other people in our group that started using Troposphere, and they had similar infrastructure that they needed to provision. And it was really hard for us to actually share that stuff. We couldn't. The thing was that the framework itself didn't have an intrinsic capability to create abstractions. And to me, this is what software is about. It's about creating abstractions. And not being able to create these abstractions was the main motivation for us to start talking and thinking about the CDK. And that's when I moved over to AWS to work with Jason and this really great team, because I thought it was a problem worth solving. So let me hand it over to Jason. He's going to tell you a little bit what we came up with and where we are.
So this is such a typical story that we've heard from so many of our customers. We've experienced it ourselves as developers. And I think the fact is really that we have this wealth of cloud services. We have hundreds of these different cloud services we can take advantage of. And our applications are using more and more of them. And the configuration for these cloud resources begins to become more and more complex. So developers really need more powerful tools for managing that complexity. And we really, really need powerful tools that let us take these patterns that naturally emerge as we put all these cloud resources together and turn them into these reusable, shareable abstractions. So that is exactly why we started building the AWS CDK. I'm going to tell you a little bit about some of the main concepts in the CDK, and then we're going to get into some code. So the CDK is a software development framework for defining your infrastructure and your cloud resources. So that code we call your CDK application. We'll see that in just a minute. Within your CDK application, you define all the infrastructure stacks that you need in your system. So that could be one infrastructure stack. It could be dozens of infrastructure stacks across multiple regions. Within each of those infrastructure stacks, you define what we call a tree of constructs. And construct is really the key abstraction. It's really the core of the CDK programming model, as we'll see throughout the session. And at a high level, a construct is really some configuration of cloud resources. So it could be a bucket, or it could be one cloud resource, or it could encompass dozens and dozens of cloud resources. So just like we saw before with Troposphere, we're still building on a software development framework. We're getting all the goodness of using our programming tools. We've got in our IDEs refactoring tools, navigation tools, inline documentation, content assist. So we've got this really rich environment for building this code just like any other code. We're still building on CloudFormation. So we've got this powerful provisioning engine underneath, and we're working with this model of a desired state configuration, where we describe the outcome in code that we want our infrastructure to be, and we rely on the provisioning engine to actually make that happen and get us there. So we talked a little bit about the programming model, and that's really what makes the CDK so powerful, is this ability to share and create these abstractions. And the CDK is really built from the ground up around that concept. But in addition to the programming model, we also ship the AWS construct library with the CDK. So the AWS construct library is a set of constructs specifically curated for making AWS infrastructure really easy to define. And we're going to be using the construct library throughout the demos, so you'll be able to see what kind of support is in there. And the construct library really gives us a lot of flexibility to easily define our infrastructure. So setting up permissions for different resources, configuring event sources, and much, much more. And finally, the CDK is a very new project. We're in developer preview. We launched earlier this summer. You can find all the source code out on GitHub, of course. It's a fantastic time to get engaged early in the project. We think it has a lot of potential to really change how developers define their infrastructure. So we'd love to see engagement from the community, of course. So I'm going to turn things over to Alad, and we're going to get in some code.
Yeah. OK. So hello, world, right? We got to start with that. That's what we came up with. It's a queue. You send a message to the queue. A Lambda function consumes the message from the queue and writes the contents of the event to CloudWatch logs. Pretty simple architecture. We're going to talk a little bit about CDK stacks, CDK applications, CDK constructs, the concepts that make up the CDK's model. We'll show you the command line interface called CDK Toolkit. And that command line interface allows you to interact with CDK applications and walks you through the workflow of working with these CDK applications. And we'll obviously work with the AWS construct library because we need to provision those resources. Without further ado, let's open our terminal here. OK, starting by creating a new directory. And we're going to initialize the project using a command called CDK init. It's basically a little templating engine that allows you to bootstrap CDK projects. It's important to emphasize that those projects are just regular idiomatic projects in every, like you do in every programming language. We've got current, as Jason said, we've got current support for TypeScript, JavaScript, .NET, Java. Python is coming up, and we plan to add more languages in the future. So let me just kick that off quickly with a TypeScript project. And we're going to use TypeScript for this demo, but you can create the exact same demo and the exact same application in each one of those programming languages. OK, so we've got our new project directory here. And it comes bundled with a bunch of useful commands. If you're familiar with TypeScript, you'll know that we need to compile TypeScript to JavaScript in order to execute it. And so we're going to run the watch command, which basically looks at files in the background and compiles them. Just open a new tab, and I'm just going to run the watch command here in the background, so I don't have to think about compiling the code all the time. OK, back to our original tab. And I'm going to kick off our ID, we're going to use VS Code, which is a really, really awesome ID for TypeScript. But naturally, you can use any ID that works for you, which is one of our main goals, to basically bring infrastructure code to your comfort zone. If you're using Java as your programming language in your team, you'd be able to use Java to provision your infrastructure. If you use TypeScript, you can use TypeScript. And our goal is to actually get to a point where we have as many programming languages supported so that you can stay in the same environment and use the same tools that you're using daily for your infrastructure. OK, let's see what we have here. So it's a regular TypeScript project. I've got package.json file with some dependencies, tsconfig for configuration. And this is the entry point that the CDK init created for us. Let me just make this a little bigger. And it comes with this boilerplate example. I'm just going to delete that for now because we want to create our own little one. And is that big enough? Yeah. And so this is an empty CDK application. You can see the application here. You can see that it contains a single stack. As Jason said, you can create applications with multiple stacks and reference resources across them and do really crazy architectures with this model. And we've got the hello CDK stack, which extends cdk.stack. And it's an empty stack. To prove it to you, I'm going to use this command called cdk synth for synthesize. And what CDK synth is doing is takes your app and synthesizes the CloudFormation template from your application. And so naturally, because this stack is empty, I'm going to get an empty template from it. OK, so first thing we want to do is we want to define a queue, right? Let me switch over to our browser. And this is our documentation website. You've got lots of information here. We're actually trying to figure out the right organization that'll make it really easy to find yourself. But there's a lot of information about concepts, the construct library, patterns, how to use CloudFormation, the low-level CloudFormation components. And there's obviously reference for all the constructs in the construct library. And so if I want to find the SQS queue, for example, there's the AWS SQS construct library. So every AWS service would have a construct library in this library, and it's still not complete. You'll find many gaps if you hit this now, and we're working on making it complete and make it as awesome as we can. But it's pretty extensive, and Jason's going to talk a little bit about things you can find there already. There's really awesome programming models there already. OK, so we want to install this library. It's just a regular library, so it would be a regular library in Maven, or in NuGet, or in PyPI, or in NPM, for our example. And so I'm just going to go back to our console, and I'm just going to install that library. So npm install AWS CDK, AWS SQS, right? And now that I have my library installed, I can import the SQS module into my code. And let's explore that just a little bit. So I want to create a queue. So I'm doing a new dot. And you can see that the library has a queue construct, or a queue class, basically. And when I'm trying to create it, I can see that this class accepts 3 parameters: parent, name, we sometimes call that ID, and properties. This pattern is going to be repeated everywhere in the CDK, because that's the pattern of creating constructs. You can even see that my stack has these 3 parameters, because a stack is also a construct. These 3 parameters allow the CDK to basically bind your construct to what we call the construct tree. You build this tree top-down. So you basically start with the application, then you go to the stack, and then you basically end up with like the leaves, which are the resources. And so the first parameter is the parent, and almost every time you would just want to say this, because you're creating this construct in the context of this construct, the parent construct. In our case, it's the class, it's the stack. Second parameter is the name. And that name maps to the CloudFormation logical ID of the resources created underneath that tree. And it's a local name. It's not a global name like logical identities, but it has the same purpose. The purpose is to be able to identify this resource across updates of your stack. And so I'm just going to give this a name. It's not the queue name. It's not the physical name of the resource. That's actually allocated by CloudFormation when you're deploying the stack. So let's call that hello queue. And we've got an optional property bag here that we can pass. We're not going to use any of those, but I just wanted to show you. You can see all the inline documentation and information about how to use these properties, and they're all strongly typed, and all those good things that you get from code, from object-oriented class libraries. Okay, so I'm just going to create a default queue, and to be honest, one of the things we're trying to do is to make sure that you're not going to need to specify anything that doesn't make sense that you would need to specify, like smart defaults, we call it, and we go a long way to make sure that you get the most concise and efficient and safe development experience when you use the construct library. Okay, so I've created the queue. Let's call CDK synth again. I'm going to go back to my terminal and see what happened. Neat. So this is a CloudFormation template, a fully legal CloudFormation template as a single resource of type SQSQ. You can see the CDK also embeds this metadata entry that allows you to map the path of the resource, the path of the construct in your construct tree to the actual CloudFormation resource, so we can backtrace really easily to find if there are any problems. And so, yeah, I've got my little queue. Let's just deploy this first, and then we'll add the Lambda function. So I'm going to use CDK deploy to deploy this. And it's going to synthesize my template behind the scenes and basically kick off a CloudFormation deployment for this. So you've seen this many times, I'm sure. And in the meantime, let's bring in the Lambda library. So I'm going to, oh, it's already done. So before we bring in the Lambda library, let me quickly do, oh, sorry. Let me quickly check that I actually have a queue here. I'm just going to use this CLI. Cool. So we've got this queue provisioned for us. Now, bringing in the Lambda library, and I'm also going to bring another library called Lambda Event Sources, which gives you some nice APIs to bind Lambda to different event sources. I don't know if you're familiar with the CloudFormation experience around that, but every event source in Lambda, it's kind of like SAM, right? Like where all the event sources have the same API. Okay, Lambda, sorry, I'm like, Lambda event sources. And, okay, same drill, bring in the Lambda module. And I'm going to bring in the event sources module too. We're going to use it real soon. Cool. And now, same thing we did with the queue, right? Like we're going to create a Lambda function. Cool. Three arguments for the constructor. This. And Lambda actually has a few required properties, like your code, right? And so the ID even tells us it needs to know some stuff, right? You can see the ones that have question marks are optional. The others are required. So we've got code here as required. We've got handler. We've got runtime. And I think that's it. Like that's the minimum requirement for Lambda functions. And so let's start with the runtime. We'll write our code in JavaScript. So we're just going to use Node. And now for our code. So if you're familiar with CloudFormation, and CloudFormation doesn't deal with runtime code. It's basically just your infrastructure. But with the CDK, we believe that we wanted to create an experience where you can create constructs that are self-contained, right? The runtime code and infrastructure code can be bundled together into libraries that people can reuse. And so we have this concept in the CDK called assets, which allows you to reference local resources within your project and bundle them into your construct. And so first of all, let's create our little directory for Lambda code, and then I'll show you how we bind them together. OK, so I just created this Lambda directory and index file. Oh, that's a directory, no. Sorry. Index file. Index. And we'll write this stupid Lambda function, exports handler, async, event. So that's the Lambda function's handler signature. And we're just going to log our event to the console. Nothing fancy here. It is like 10 times longer than any hello world you've ever seen, right? But still, it's like you'll see the template soon. OK, so we've got the Lambda code. And now all we need to do is tell the CDK, hey, use this directory called Lambda as your asset, as your runtime code. And it's actually pretty low level. It's more low level than we want it to be. Like, we actually want to provide an even higher level experience for you to be able to reference your code much more naturally for every programming language. But at the lowest level, you can just tell it, take this directory, zip it up, put it in S3, reference it from my CloudFormation template, do all the hula hoops that you need to do in order to make this code work. And so I'm just going to put Lambda here, right? That's all I need to do. Last thing, I think, is the handler. OK. Handler is the name of the handler, right? Like, it's index.handler. OK. Almost done. Now we need to connect the Lambda and the queue, right? Like, we need to actually get the Lambda to consume from the queue. So in order to do that, we need to be able to talk to the queue and talk to the Lambda function. And so I'm just going to assign those to local variables. And if I'm exploring the API I have for my Lambda function, it's a pretty rich API. For example, it lets you create metric objects and assign them into dashboards or create alarms from them. Like, there are a lot of really cool things. And we have a lot of really cool ideas also. Like, not everything is here in, still. But there's a lot you can do with this already. Aside from all these, we've got this add event source method, which allows you to add an event source to your Lambda function, presumably. And the signature says, I need an iEvent source, and then there's some documentation that says you can use the event sources library, blah, blah, blah. And so we're just going to do that. New event sources dot. And you can see there are only 3 event sources here, but there are like 12 different event sources for Lambda. And we're just working on those, and we'd love your help, and pull requests, and plus ones, and all those. OK, and then I need to just pass in the queue. And that's it. So basically, this is how I connect a Lambda function to an SQS queue. And let's synthesize this for a second. Oh, before we synthesize this, I actually wanted to show you another command called diff. Diff is pretty cool because it allows you to take your current application and compare it to your deployed stack and see what will happen if I'm actually going to deploy this. So let's do that for a second. And before I show you the diff, I'm just going to run deploy because it'll take a second. OK, so we see the diff information. We see that there are going to be a bunch of resources added to my stack. We see the Lambda function here. We see the event source mapping that maps the Lambda function to the queue. We see the Lambda role and policy. And we also see a bunch of CloudFormation parameters, which are part of the asset magic that basically binds those assets to our code. And if I take a quick look at the actual templates that's generated, let's do a JSON version. I kind of prefer JSON sometimes. You see, this is technically what I would manually need to write if I wanted to create this hello world example with what we call raw CloudFormation. And so there's a lot here. It's not trivial. And one of the interesting things is that you can see that it's created an IAM policy for me for my Lambda function that allows this Lambda function to consume from this queue, right? Like that's required. Like there's no way for this Lambda function to be connected to the queue without this policy. And for those of you who have dealt with anything at AWS, that's probably one of the biggest pain points. At least it was mine. OK, I think we're done. Let's see. Yep. Let's go to our Lambda console and see what we have. Lambda console. You've changed the icon, I think, this past month. OK, so we've got our Lambda function. And we can see that it's connected to our queue. We can see the permissions here also, with all these nice set of actions to consume from the queue. And if we open the SQS console, let's try to actually send a message. I think the official one is like that, no? OK, send. Now the comma is going to blow up the demo. OK, I'm back to the Lambda function. I'll open the CloudWatch logs, because that's where I expect this to be. And we've got a log group. Still working. Yay. Hello, CDK. Cool. So quick recap. We saw how to initialize CDK projects using CDK init. As I said, those are just regular projects. There's no magic to them. And we can add more templates if you feel that we need more templates. We saw how to use the CDK toolkit in order to interact with your application and help you with the CDK workflow. You write your code. You use this toolkit to synthesize, diff, and deploy your application to your stack. And I'm going to hand it over to Jason for another really cool demo about writing constructs. Cheers.
So we've seen the basics of using the CDK now. We've seen the CDK CLI. We've also consumed some constructs from the construct library. So in the second part of the demo, we're going to take things a little bit further. And we're really going to look at not only consuming constructs, but how we create constructs and use our own custom constructs to shape our code. So we are going to create some custom constructs in this demo. We are also going to learn a little bit about the permission system in the AWS construct library and talk about how our runtime code in our Lambda function actually communicates with the infrastructure we create in our infrastructure code. So you can see from the architecture diagram, we're going to refactor our code a little bit. We're going to pull out this queue recorder construct. And then instead of just logging to CloudWatch logs, we're going to pull in a new module from the construct library. And we're going to start writing data to a DynamoDB table. So let's go back to VS Code. And the first thing we're going to do is pull out this new queue recorder construct class. So this is just like any other code, of course. We're going to create a new lib directory and a queue recorder TypeScript file. And then the first thing we need to do is import the CDK framework, of course, so that we can access construct and all the other classes we need. And then we're going to export a new class called queueRecorder that extends CDK construct. And let's go ahead and fill in our initializer. And we're going to follow the same pattern that Elad showed you earlier in the demo. We're passing in our parent. That's of type CDK construct. We're also going to pass in our ID or our logical name. That's going to be of type string. And we'll just pass those up to the superclass. So this is the simplest construct we can write. Doesn't actually do anything yet. So let's go and pull some of our code over from our main CDK application. So let's grab this Lambda function and also this code that configures the event source. And instead of having all the details in our main CDK application, we're just going to shift some of that into the queue recorder class. And we can simplify our main application a little bit there. So let's go grab these imports. Don't need those anymore. OK, so our code's looking pretty good now. We just have one problem down here we have to fix. So before we could just directly reference this queue, now we're going to have to pass in the queue to our construct. So we're going to follow the same pattern that Elad showed you earlier, where we have these property objects that we pass in as the third argument. So let's create a new interface, and we're going to call it queue recorder props. And the only thing we need to put in here is our input queue of type SQSQ. So now let's update our constructor to take in a new props member of type queue recorder props. And then we're just going to reference that down here and pull out the input queue. Cool, so that's all it took. Just like any other code, working with our infrastructure definition is now just as easy as refactoring any other code. So let's go back to the main CDK application and actually use this construct. So we're going to create a new queue recorder. And we're going to pass in this as the parent in the construct tree where we want to attach our new construct. We're going to call this our queue recorder. And then we have to pass in the input queue that we just saw. And of course, that is just a queue. So I'm going to go ahead and just update this real quick after our refactoring. And while that's running, let's go ahead and add the DynamoDB table to our system. And then we'll change our Lambda function to start writing our data to that table. So going back into our queue recorder construct, so we're going to put the DynamoDB table in here so we can keep all that complexity kind of wrapped up behind this queue recorder interface. Oops. And just like we saw in the first demo, the first thing we need to do is bring in this new module, the DynamoDB module from the AWS construct library. So we're going to npm install AWS CDK, AWS DynamoDB. And after we've added that to our project, we can go up here and import it into our code. Oops. So just like we saw for all the other modules in the construct library. And then it should not surprise you that we're going to create our table the exact same way we created our other constructs. So new DynamoDB.table. We're going to pass in this as the parent in the construct tree where we want to attach this new construct. And we're going to call this our queue recorder table. And we've got to pass in one property for a Dynamo table. Let's assign this to a constant too. So when we're working with Dynamo, the one attribute or the one parameter we need to pass in is our partition key and specify which attribute is our partition key. So we're going to create an attribute with name ID, and type is just going to be a string. And we're going to use an enum in the DynamoDB namespace to grab that string attribute type. So that's all we have to do to add this table to our system. The next thing that I want to do is jump over to our Lambda code. And we're going to replace this really simple console logger with some code to write to DynamoDB. So we've already got this. We're just going to pull it in from the clipboard, and then we'll explain what the code does. But we've still got a really simple Lambda function. We've got 19 lines of code here. We're pulling in the DynamoDB library from the AWS SDK. And we're using the DynamoDB client to write all of the records in the events that come into our Lambda function. We're just going to write all those records to a Dynamo table. So the interesting part of this code here is that we have to have our runtime code able to talk to the infrastructure that our CDK application code is creating. And what we do, we use a technique where we pass in the table name as an environment variable. So at provisioning time, we are going to get CloudFormation to wire all this up together for us so that our Lambda function has this table name environment variable set and is able to just work with that table name without having to do anything else fancy to figure out what was the actual table name that CloudFormation provisioned for us. So that's how the Lambda function knows which table to write to. But let's go back to our queue recorder CDK code and talk about how we actually supply that information to the Lambda function. So let's go and explore the function API a little bit. Right here on top, you can see we've got this method called addEnvironment. And this is going to let us specify any environment variables that we want to pass to our Lambda function code. So we are going to pass this table name environment variable. And then we're going to set this by grabbing the table construct and just asking for its table name. And even though we don't know what that name is now, when CloudFormation actually provisions all of this for us, it's going to wire everything up correctly so that this table name environment is set with the actual table name, the physical name of the table that's created. So we're pretty close now. We've got our code refactored out into a construct. We've got this new DynamoDB table, and we've got our Lambda code updated to write to this table. So we're very close, but we're still missing one piece. We haven't actually granted permissions for our Lambda function to be able to write data to that table. Of course, permissions are always locked down by default, so we have to explicitly grant any permissions that we want to add to our system. So one of the things that I think is really, really exciting about the AWS construct library are all these grant methods. Whoops. So this is how you explicitly give permission for different principals to work with different resources. It's going to be very clear syntax. It's going to be very explicit. And we're going to get a nice, tight least privilege policy that only grants permission for specific operations for one specific resource. So security best practices, very easy and very clear in the code. We're going to use the grant write data because our Lambda function just needs to pump data into this function. And then we need to pass in the principal that we're granting this permission to. So we can do that by grabbing the execution role in our function. So we just grab our function context and ask for the role. And that's all we have to do to wire up this permission. The code is really simple. It's very explicit. It's very clear what's happening. And we really didn't have to dig deep into some of the assembly language of the CloudFormation template to do this. So let's go ahead and take a look at CDK diff now that we have updated all of our code and see what's actually going to happen when we deploy this. And to save a couple seconds, I'm going to go ahead and kick off the deploy as well. So we can see this new table that we created. We expected that. We can see that our policy document has changed a little bit. Alad explained how we had permissions to work with SQS before. And now you see that we have some new permissions added here. So we now also have permission for the role that's executing our Lambda function. Also has permission to work with just a few actions in the DynamoDB API just for that one table that we granted permissions on. So very easy to lock down our permissions nice and tight. And we can also see this Lambda function down here that we had this new environment variable that we specified. So let's give this another minute for this deploy to finish, and let's go back to our slides and do a quick recap. So in this second part of the demo, we saw not only how to consume constructs, but how we create our own constructs and use them to simplify and shape our code. We talked about the permission APIs, the grant methods in the AWS construct library. And we talked a little bit about a technique for enabling your runtime, your application code, to be aware and work with the infrastructure that CloudFormation provisions for you. So let's see how our deployment's going. We finished. So let's jump over to the SQS console again. And let's go ahead and try sending a message. And with any luck, the message will be picked up by our Lambda function and written to our DynamoDB table. Let's go ahead and send 2 messages. We'll see if both of these make it over to Dynamo. So over in the Dynamo console, we've got our table that we just created. And if we look at the items, sure enough, we can see hello CDK1, hello CDK2. So the demo is working, and we have our messages flowing from SQS to Lambda into our DynamoDB table. So I will turn it over to Alad to take us through the last final part of the demo.
Thanks. So we saw how to organize your application using constructs, and you can do a lot with that. Like, if you think about it, complex cloud applications consist of multiple components, and infrastructure is becoming part of the application. It's not an external part. And so being able to model those mental models using object-oriented techniques is a very powerful capability that we see customers do pretty amazing things with. The other nice thing about constructs is that you can use them to share infrastructure components. They're just regular classes, like any other class that you share. And so you could publish them to package managers, whether they're internal to your company or in your team or to the public package managers. So I spent some time a couple weeks ago over the weekend writing this cute little construct library called Twitter tweet queue. I published it to NPM. It's pretty cool. It would basically give you an interface of a queue that contains tweets from a Twitter search. So you just specify your query, and this Twitter queue thing, it has a few moving parts in it. It has a CloudWatch events that triggers a Lambda function that pulls Twitter checkpoints through a DynamoDB to make sure that it's not repeating any tweets, and then publish them to a queue. And so you can consume the queue naturally as a queue, but there's a bunch of things happening here behind the scenes. And so let's just plug that queue into our little hello world application. It's gonna plug in pretty cleanly. And there's some documentation here. You need to install this module. It's an NPM module. Let's do that. OK. NPM install, the star of the demo, CDK tweet queue. And I'm going to go to my main file, import tweet queue from CDK tweet queue. Sorry. Equals CDK tweet queue. And let's see the API here. New tweet queue. And it's a construct, surprisingly. So I'm just going to bind it to my stack, tweets. And if I'm looking at the set of properties here, again, a bunch of optionals, a bunch of required ones. The two required ones are the secret ARN, the secrets manager ARN that contains the Twitter credentials. And so we've actually uploaded before, so I'm not going to need to do that. I'm not going to need to upload it. I'm just going to paste in a little ARN here. So that contains my Twitter credentials, so I can actually hit the Twitter API. And the second required parameter is the query. So I'm going to use hashtag AWS CDK, and you're going to need to help me fill up that table with by hashtagging your tweets. And I'm just going to basically replace this queue with the tweet queue, because a tweet queue, if I'm looking at the tweet queue definition, you see it extends SQSQ. So it's basically an SQSQ as far as everything polymorphically is concerned. So I'm just gonna do this. I don't need this guy anymore. And let me kick off deployment here. And I just want to quickly show you what's going on here. Sorry, CDK diff is probably more. So this is basically what this little one line of code, or 4 lines of code added to my stack. Like it's added a queue, a table, a role, a policy, a function, a permission, a CloudWatch events rule, an event source mapping, and it modified our policy. By the way, this policy view, diff view, is hopefully going to change. We have a pull request and for nice, really UI for showing you exactly what permissions are going to be changed in your stack. And so let's go back to the slides for a second. The point here is encapsulation, right? Like it's a very fundamental principle in software design, and we're really excited the CDK is enabling that around infrastructure. All I needed to do is basically bring in this tweet queue class And behind the scenes, this class had like lots of implementation details and quite a lot of resources. It could be hundreds of resources behind this one little class. It provided an API that worked against a specific mental model that they designed, right? Like it's not about the resources, it's about what this thing is actually doing. And it plugged really nicely with my existing application because everybody's speaking in these construct language, right? So while this is deploying, I think it's going to take a little while because of all those resources. Jason's going to do a little summary and tell you what more you can explore.
So I'm going to recommend some areas to go explore more for the CDK. While I'm doing that, please help us out and hashtag AWS CDK, send us some tweets. My first recommendation is definitely to go explore the AWS construct library. Remember that this is the curated area where we define the experience for AWS infrastructure. And there's a ton of really awesome functionality there already. If you want to go build an application with containers, check out our ECS, Fargate, and ECR support. If you want to build a serverless application, we've got great support for Amazon API Gateway, AWS Lambda, and AWS Step Functions as well. We've also got nice support for code pipeline, code build, code deploy. So you can use the CDK to manage your whole build and release infrastructure as well, too. There's a ton more. There's great support for EC2 if you want to work at a lower level, manage VPCs very, very easily, security groups, CloudWatch metrics, alarms, and dashboards. So tons to go explore. If there's something missing in the library, raise an issue on GitHub, or better yet, send us a pull request. We'd love to hear about it so we can help prioritize based on customer feedback. And we've really focused on TypeScript today. My second recommendation is to go explore some of the other language support for CDK. So we've kind of hinted a little bit at this idea where the CDK is really available not only in TypeScript and JavaScript, but also in Java and C#. We've got some experimental support for Python in the repo already that you can check out. We hope to include that in the official builds very soon as well. But I think one of the really neat things about CDK is that we're able to take this programming model and this AWS construct library, and we're able to map it consistently into all these different languages and keep it in sync across the different languages. And we're able to do that by using another open source project we created called JSII. So that's another really interesting area to explore. And then, so of course, we're really just scratching the surface in an hour of what you can do with the CDK. There are already support for a lot of pretty advanced use cases. So if you, for example, have a big application that runs in multiple regions, that's easily supported with the CDK. If you have a big investment in CloudFormation templates already, you can take those templates and embed them into your CDK application without having to port them all over to code if you just want to start migrating over to the CDK. And there's a ton more. Check out the docs and ask us questions on GitHub. And then finally, some kind of higher level resources. If you're just looking for some easy ways to get your hands on some CDK code and learn, there's a great workshop online at cdkworkshop.com. This is a nice guided workshop that's going to help you build a pretty cool application using Amazon API Gateway and AWS Lambda to build a neat little serverless application. You can also find our docs linked from GitHub, and we'll have the source from this sample application up on GitHub as well later today. And of course, if you want to reach out and engage a developer team, we'd love to hear from you on GitHub or Gitter or Twitter. And there are a couple of related sessions as well that'll have a little bit more CDK content in them. So Dev411, Infrastructure as Code, AWS Best Practices, is available 3 more times this week. This is a chalk talk, so it's going to be a little bit informal and lots of chances to ask questions. There'll be a couple of engineers from AWS Developer Tools there and showing off some CDK code as well. Dev372, Beyond the Basics, Advanced Infrastructure as Code Programming on AWS. There's a chance to catch this session on Thursday. This is going to be an overview of some of the advanced features that we've added to AWS CloudFormation in the past year. So that'll be a cool one. And last but not least, Dev309, CI/CD for serverless and containerized applications. This is probably the first session I'm going to check out as soon as they're uploaded to YouTube. Phenomenal speaker, and it's going to have a lot of CDK content in there, and really something for everything, or something for everybody with CI/CD, serverless, and containers. You can catch that one later today or on Thursday.
Let's check the tweets.
Yeah. Okay, so this is the moment of truth. We'll
It's
see.
going to be an anticlimax, believe me. Dynamo table. Yay.
Awesome.
Flawless demo for AWS CDK. Yeah, that's a good one.
Thank you all for tweeting.
Thanks for coming. We're going to hang out here. We've got some CDK stickers, the first ones ever. We'd love to talk to anyone on the Getter channel who talked to us and is maybe here, and we'd love to get to know you. And thanks so much.
Yeah. Thank you.